Hi, I'm Scott Alberts at Truman State University, and I'm a statistics professor here. And I'm just going to walk you through some of the web pages that are kind of summarizing COVID-19 data and maybe explain a little bit about what's going on in them. So, I made a short video at the beginning that you might want to watch before this. It explains the difference between exponential curves and logistics curves, because that's going to be really important. And I also talked about how log linear transformations turn exponential curves into lines, which makes it really easy to see when you are moving from an exponential experience to a logistics experience. So the first web page I want to talk about is the Johns Hopkins site, which really is sort of the best site for collecting data. This data is updated at least once a day. You can see it was done this morning, about a half hour ago. And it has a nice map and it has other features. Down here, it has kind of the overall cases. And you can see how right now it's starting to look like an exponential curve. And what we're wondering is, are we starting to see it curve off? Is it starting to become a logistic curve instead of an exponential? So that's where this log transformation will happen. It converts an exponential curve into a straight line. And you can see that here it was clearly exponential. And then just here in the last couple of weeks, we started to bend the curve, as we like to say. They also have a nice graph of daily cases, and this is how many new people have been diagnosed. Of course, the number of people diagnosed is hard to track because the number of tests really vary, and the prevalence and convenience of testing really varies from place to place. So if you look at somewhere like Germany, where they really have started to bend the curve in a real way, one of the things that's really helped them is their ability to do a lot of testing. And if you scroll down here to South Korea, which remember was one of the first places to really see the virus, you could really see how they went exponential and then flattened their curve. And you can see here how they've really started to look like a logistic curve in practice. Well, China does as well. Where did China go there? Their logistic curve is here. And again, if you turn that into a line, you can see how they've bent the curve. Again, this is new diagnosed cases, so it's a little bit misleading to think about when we don't really know how the testing is done or the different conditions. So the other projection that I want to mention is here at covid19.healthdata.org. And it's really trying to project what we think might happen into the future, because of course, predicting the future is what we want to do here. So it takes our current data, it focuses on deaths rather than diagnosed cases, because the idea is that you're going to be more accurate with diagnosed deaths. It's a little bit more morbid, but I think it really does hammer home the point. And you can see that it does look like we've peaked. You can also see that the line is not smooth. And even though we like to make those mathematical curves that are very smooth, in practice, that's not really what you see. Here is kind of the use of hospital beds and ICU beds, and you can see again that we've peaked. They do have a projection of the uncertainty of it, and you can see that it's huge. And some of that has to do with whether or not social distancing practices are conserved. This site also has a nice thing that'll break it down by state. So I'm gonna look here at Missouri, because that's where I am. And what you can see is it actually tracks the different rules and the different conditions. It actually suggests that June 1st is when this model thinks that we might be able to open up some and do some containment. Of course, that's 6 weeks from now. So a lot of people are talking about doing that sooner, but they really think you need to get down to fewer than one case per million before you start opening up as we do that. Again, you can see the curve is very bumpy. Of course, local data is even more bumpy than national data, which is summarized across things. You can see that we didn't hit the maximum for hospital beds or ICU beds, so that's awesome. And their model predicts 362 deaths. I will say when I first started looking at this site, it predicted 2,000 to 3,000 deaths because it started before the stay-at-home order was in place. When St. Louis and Kansas City put their order into place, this model went down to 1,300 projected deaths, and now that it's a statewide stay-in-place order and our neighboring states also have them, the model has gotten even lower. So this site is really good to get kind of this daily update of the model. Let me look at one more here, and that's New York, because of course New York is where the action is, I'm afraid. And you can see, of course, their numbers are higher than Missouri. They have more people. And they had a peak and then a dip, and now they're expecting a second peak, which should go down. Again, June 1st is when they model. They'll be able to open up, and they're predicting 21,000 total deaths in New York. And again, that number was much higher before. One other state to look at is Ohio, which remember was very close, and they've actually already started their downward trajectory. Washington is one of the first states that had the outbreak, and you can see that they're almost all the way down, and actually this model says that they can open up on May 18th, so that's in only a couple weeks, using the containment strategies. And again, they've pretty much hit their curve. They've bent the curve, as they say. A site that has data that's similar to this, but a little bit different, is this one by atishb.com. Atish Bhatia is actually a physicist who does Minute Physics. He's one of the collaborators there, which does some cool visualizations. And one of the things that he really noticed is if you just look at cases per week versus cases confirmed, and you do that log transform, you can see that pretty much every single country falls on top of each other until they get it under control and the numbers start to curve down. You can see the US under this is just starting to do that. If we don't do the log linear transformation, we look at the regular one, you can still see those numbers going. And again, this is just new cases per week is the y-axis and the total confirmed cases, and you can see the US has started to level off, but when you convert it to that logarithmic scale, you can really see what's going on there. And again, you can see which countries have successfully bent the curve. One that I do want to mention on this chart is Sweden, because remember, Sweden didn't do the social distancing, and even though they started a little bit later, they're actually pretty much in trouble right now. We can switch this to just look at the US states, and you can animate it again, which is kind of fun to do. They have only the biggest states with the most cases on here, but I'll put Missouri on here as well. And you can see Missouri did start to bend the curve here in April. So our social distancing did seem to work there. Again, the idea that if you do animate it, you can see how the states just go right one on top of the other. And again, they don't put all 50 states on here and the territories on here because it gets a little bit busy. But if we do that with the animation, the fact that the chart lines up almost perfectly on top of each other with this straight line tells us that in its natural state, COVID-19 spread is exponential, at least in the short term. Now, it is also true that the curve will bend on its own once everyone has the disease, but we sort of don't really want to fall into there. Anyway, this is a nice chart, atishb.com. A related one is 91divik.com. And you can see the idea is we're going to flip the script so it's COVID-19 backwards.com. And it has this same chart by country, but now it has them charted, and you can actually pick whether you want to look at new cases in the past week, which is what that other chart had. You can look at deaths, you can look at a variety of different measures. Again, you can look at the linear scale, which shows you this exponential curve. Again, the deaths by this curve, I mean, it looks pretty exponential to me. And again, we're hoping that it will start to level off. You can see deaths have started to level off, which could mean that we've had it. And again, when you turn that back to the log curve, you can see, again, that we've done that. It also lets you change where your straight line is that you're comparing against. So the idea here is that 1.06 is 6% growth per day. And that one that it started with was a 35% growth. And it does look like that's kind of the natural slope of the exponential curve when things happen. So that would be e to the 1.35 if you're thinking about it as math, which maybe you aren't. And again, this page has the state level data as well, so you can see how the different states compare. Again, you can see that a lot of the states have started to curve just here in the last while. And again, that's true whether you look at cases or deaths. A couple more charts I want to just show you real quick. This is showing the same data that we saw before, but it has a little bit different trajectory. This is visualcapitalist.com. And in the beginning, it was one of the first sites that went live. But what's kind of interesting about it is it has different slopes for the different doubling rates. So instead of thinking about it as a 3% growth or 6% growth, it wants us to know how long till it doubles. 1.35 doubles every 3 days. And so here you can see that the US was actually right at that for a while and is now starting to level off. If we look at the Asian countries, you can see China's pretty much gone flat. Japan, South Korea have gone flat. People like to talk about New Zealand in Australia, which of course have the advantage of being islands separate from other places. So quarantining visitors actually helped with that a lot. South America and Africa are really just behind, that they got the disease much later. Oops, let me take Asia off here. And you can see that they've been able to contain it a little bit better as a result. One more chart, COVID Act Now. It shows under different orders what we might expect to see. So this is the prediction of what hospitalizations would look like if we lifted the stay-at-home order completely right now, how it would peak up. If we keep our trajectory right now and we don't open up, this is what they think will happen. You can look at it by county if you want to do that. Of course, our county is small, so it's hard to get too much difference. But again, we're expected to have 4 hospitalizations or 60 if we have lax stay at home, or 241 if we lifted the order altogether. So this is another good site. All right, the last site I want to look at is an RT site. And RT is the idea of how many people get infected by each sick person. So if RT is 1, that means each sick person makes 1 more sick person. So if it's below 1, that's the beginning of containment. Interestingly, RT is also a thing they use when they're fighting fires, because you think about how fire spreads. If the RT is high, that means the fire is spreading, and if it's lower, that means we're starting to get it under control. And what you can see is right now, most states are now below 1. The couple that aren't, Nebraska, North Dakota, Ohio, Iowa, Kentucky, they still have high numbers. But more interesting than that is you can see how these numbers have changed over time. And they're ordered by high to low right now, but you can see how these numbers have moved in the last few days and few weeks. And then the last thing it has is it just has a graph of each state. And again, Missouri is right here, and you can see that we've lowered that number a lot from the high that was 3.8, and now we're down below 1. And Ohio has had a couple bumps, which is a little bit scary. Pennsylvania actually got good and then popped up again. New York has been moving in a good way for quite some time, but again, they had an uphill battle. Washington, again, they're having their second peak that is a little bit scary, but it looks like they've turned the corner on that. So this has just been a quick look at some of these various maps and how the different web pages look at the same data in different ways. Every site I showed you pulls data from that Johns Hopkins site, because that's the one that really collates and collects it, and then they just explain and display it in different ways. So if you have any questions, shoot me an email. I'm at salberts@truman.edu, and I'd love to talk to you about it. Otherwise, thanks for watching.